Good day, guys. Can you hear me? This is Chin speaking. Yes, okay. What's up, guys? Once again, welcome to this third course of application analysis. Before today's course, let's first review the course we learned about yesterday. Yesterday, we learned about the spatial analysis, including the general knowledge about the query in Superman and the vector analysis, and as well as the raster analysis. With this basic knowledge, we create two maps with spatial analysis. The first map is with the proximity analysis. We created Tyson polygon for these stations, and we also use the raster analysis interpolation to get the result of the interpolation of precipitation distribution map, and then we made a layout of these two results, and finally we can analyze the results based on this map. So today we are going to the third session. It is about the network analysis. On today's course, also divided into two parts. The first part is the general knowledge introduction, and the second part is the demonstration. So let's go on the first part, the general knowledge about the network analysis. So this part you may either need to understand what is network analysis because it exists in our real life, such as the roads and also the rivers, pipelines, such like this. So the network analysis is a process to solve the practical problem by analysis in network model, such as the path analysis, service area analysis, and closest facility analysis. So it is usually used for these areas, such like the electronic navigation. We usually use the electric map to guide to create the route to get us from one place to another, and also so that's this for transportation application, and also used for tourism and also for urban planning, and also logistics, so that we can know how can we deliver the goods from one place to another place, or from one place to multiple places. And there are two models in network analysis. The first one is transportation network models, and the another one is facility network models. As this slide shows that the transportation network is a network with no directions, in which the commonest is route transportation network. And the transportation network analysis is often used for the route searching and location finding. And the facility network model is the network with directions, commonly including petroleum or gas pipelines, rivers, and others. Such a network is a directed network. whose flowing directions decided by the sources and sinks in the network. So we know that just like the rivers, it has the flow directions. It must flows from the higher point to a lower point. So does the gas pipelines, also the water pipelines. This belongs to the facility network. And for the transportation networks, we often encounter this situation. We usually want to know what's the shortest route from one place to. So here we can use the transportation network, the optimal route analysis to find out the shortest route from one place to another. And another situation is that as you may want to choose a route which can pass to the most points of the interest and attempt. Suggest you are in a city and there are many places you want to visit. So here we can use the route plan to achieve your destinations. So also the another question is about you often want to know what's the service area of a supermarket. So you may want to know which supermarket is the closest to you or to a certain place. So this is all associated with the transportation network analysis. In addition, the transportation network can also provide the navigation functions, or also the route plan or transfer analysis, and also indoor navigation functions. And for the facility network model, we know that like the common facilities, just like the water network, transmission lines, gas pipelines, telecommunications networks, or water system, and others like this, all these networks resources are flowing directionally, so which can be modeled and analyzed with the facility network model. So here the facility network provides provides many methods for your application, just like the critical element analysis, connectivity between 2-point analysis, or single element tracing analysis, or multiple element tracing analysis, and also the adjacent element analysis. And for the time limits, I won't explain this for you, but you can, if you want to know about it, you can find these details in the help document. So when we talk about the network analysis, we often need to talk about what is the topology. We know that the topology studies the property of remaining unchanged when geometric objects were bended or stretched. So here are many rules for you to check the topology of the data. Just like here, the picture shows that 4-point the 4-point analysis. There may be a rule that must be covered by line, or must be covered by boundary of region, or must be properly inside polygons, and something like this. And also just like this for the line and the regions rules topologies checking. Here the rules like must not intersect with each other and must not intersect within the line itself, such like these rules. And for the region and regions relationship, we can check if these two regions meet this meet these rules, just like must not overlap, must not have gaps, or must not overlap with such like this rules. So this is about the topology. So why we need to check the topology? So first, the basic cleaning of the topology processing is to lighten the manpower in data checking. So here we can find the topology errors and fix with topology editing tools. And the second one is we usually have the application of converting the lines to polygons. So here we must to check the topology of this lines. If the lines can create an enclosed errors. So, and the third, which is the most important, is for the network dataset construction, also for the network analysis. We know that the network analysis can't without the lines. So here the network dataset is a dataset that contains not only arcs but also nodes. So it must so the topology relationships must to be checked before we could construct the network dataset. You may wonder what is the network dataset. The network dataset contains not only arcs but also the nodes, and the topology relationship exists between the node and node, or node and arc, and arc and arc. So for the transportation network, the network dataset is a model which is composed of a group of interrelated arcs, nodes, and their attributes, such that the roads are the arcs, and the cross or the stops are the nodes. So, and for the facility network, the network is composed of a group of edges and junctions. So it can be used to express and model the real-world network facility according to the specified connective rules. So when we create the network dataset, we can get we can get a group of arcs and nodes which have the topology relationship. So that's why it is important to check the topology before we create the network datasets. Also, why it is important for the network analysis. They should at desktop also provide the topology topology checking tools, such as the 9 dataset topology processing. With these tools, it is easy for you to check the road topology. So here we can see the topology errors. We can check all these rules, so it can be automatically checked the errors and then fix it. So that's all about the general knowledge about the network analysis. Then after that, let's go to the second part, the demonstration. This section mainly uses network analysis to achieve the analysis of public service facilities service error, to help us understand the serviceability of existing public service facilities, and then help us make better decisions for urban planning. So for this session, we need three types of data. First, actually, it is the road data, and then it is POI data, and also we need the administrative data. And let's take a look at the workflow of today's work. The first, we also need to process the original data, and then we use the data to do the network analysis, and then out the results. Finally, we analyze the results. Here we can show first thing we should prepare a road data, and then create network data sets by this road data, and then we import the public service facilities, such that this session we will use the hospitals data. So we are going to discover the hospital service capabilities in Bangkok city. And then finally, we can get the hospital's service error. So now let's go back to our desktop. So let me close the maps created yesterday, and then here we need. So we need the first one. We need a road data. Road. I think I haven't import the road data before. So here, let me import the road data. I will also use the OSM data. We are going to find the road. Here's this one. And import it. The shape file, the road shape files stored all countries' road data, so it is big enough, and it takes time to import. Here we can see there are more than 2 million data. Let's wait. During this time, let's continue to see the following content. And also, we need to lay out the analysis results. We should end a title and also the scale, the north arrow, and also the legend. Here, this mark means hospital, road, and the boundary of the city and the service area. And the last one is the results analysis. So here we will talk about it after we finish the network analysis. And also today's tutorial has been already published on Google Classroom, so you can download this tutorial and following this tutorial to finish today's assignment. I think it almost finished. Okay, or 90% finished. Just wait. So here, what we are going to process the original data. As you see, there are so many data. So we need to do the filter or clipping to get the data we can use. And then first it is the raw data. Let's take a look at in the map. So here all countries roads. So it is amount of data. And thinking and to kind of. So in this course, we will not use the whole country's data, but only cities roads to do the analysis. Just to for this course, I just use the Bangkok, the cities, to analyze these cities roads. So you can choose any cities you'd like to analyze. Here, how to find the cities, just like the last course I introduced to you. You can, if you only want to select one city and you know where the city is, here you can use a simple query to just find the city you'd like to, the Bangkok. And also you can use the circle query to search the city you'd like to and see the results. Yesterday, a student asked me why I use circle query but not use a spatial query. Just like I mentioned that the circle query can use for the non-spatial data and the spatial data. So and this spatial analysis often used for the spatial data, and the spatial data or the spatial analysis query often need you often know the relationship between two features. You just like here I and the roads and the administrative data and the map. So here I know the if I know the roads and the administrators relationship, just like the intersection or cross or contain, we know the spatial relationship. So we can use the spatial query to find out it. But if you only want to query one data set and you just know the conditions, just like I want to search the country named Bangkok. So here we should use the circle query. Here we can set the condition like the city's name equal the Bangkok city. So here we can find out it. And now I know where is the Bangkok city here. So here I just use the simple query to select this one and then right click at the Bangkok city attribute table and save as data set. Here we type as the next as region and okay. So here I can enter current map. And then here we can use spatial analysis to find out which roads contains by the city. So here we know the relationship between the city and the roads. So here we can use this spatial analysis. We first connect to the Bangkok city, the city data and the spatial query. And here we want to find out the roads contains by the city. So here we should set the spatial query condition. Maybe contain, destroy, intersect. Here is the expression of each operators. Contain return objects in the search layer contained by the searching object. And here also the intersect. I intersect with searching error. So here we can also use the intersect and save the result. Now we can check the attribute table. We still have more than nearly 20,000 data. And we can add to current map. So here we can say if you use the intersection, the intersection rules, the roads are outside with the city or select or output. So here we need to change the operator as contain. Let's see the difference. If we select contain, the roads intersect with the boundary will be clipped. Here is the result. Let's take a look at the result. So here we can get the roads only contained by the city. So that's our purpose. Here we can delete this one. Then but here you can see there are still so many roads and here the F-class fields have the we can see the level of the roads. So for the demonstration, I'd like to only use the main road to do the analysis. So here I'd like to just select the primary road and all the secondary level road. Here we are also going to use the circle query and find the road layer. Here we select, we will output all these fields and then the F-class feature. We can get the feature. The primary. And here we also here we need to combine multiple conditions to select the result. Find out the secondary. Link. So here we put these conditions, the combined conditions, and then here we local road, main road. And so here we can see there are only more than 6,000 data here. Now all primary data and second level data. So here we are going to use this data for better better application. And so here we can see the main road in Bangkok City. And here we prepared the road, and here we need to select hospital from the POI dataset. Then let's find out the POI. We can find out the if class have the hospital. Here we have also use the circle query. Here I think we can because here you can see the original data is include all countries POIs, but there we have two conditions. The first condition is that the hospital is in Bangkok City. There are two conditions. The first one is the POI is in the Bangkok City, and the second condition is that we only want to we only want the hospital POI. So here we can also use the spatial analysis. Here I want to show you how to query these results by multiple query conditions. Here we first also select the city's boundary and find the spatial analysis, spatial query. Here we select this POI and set the spatial query condition. Here we select contain. So the points must be in this city, and then here we can attribute query condition. So here we can also set the yeah. Here we just click here. This we can set the circle expression that is the F class this field equal hospital. Okay, and then we save the result. Google hospital. Okay. I close this layer and just add this. Here we can see, and here let's check the attribute table. They are all hospital selected, and the hospitals are all in the cities. Let me change the names. So here we almost finish the data processing, and the next step is to do the network analysis. Just as I mentioned before, we are going to do the network analysis. We should create the network data set, and before we create the network data set, we should check the topology of this data. So here we are going to check the roads topologies by data and the topology diagram. Oh, no, just the topology we have. Here we can see the topology checking. Here we can bind the data. Here we can see the topology rules. the rules are different for the points to points, points to lines, and points to regions or lines to regions. So here we just need to check the roads topology. We can just use a line checker. Here it is easy to use for you. And here we select the road main, and here we can check these errors, and it will automatically fix these errors. Okay. Yes. So here it finished checking, and then we can generate the network data sets. Here we find the traffic analysis with network analysis, transportation analysis, and the vicinity analysis is under spatial analysis, network analysis. This is vicinity network analysis. So here we're going to do the transportation network analysis, and then network dataset by topology structure. Here we select the main road and the network. And here we see the row as split line by point, and okay. And let's take a look at the result. Here we can see the network dataset has the topology relationship between the roads and the points. And then up and to the current map. And we can see this is the network dataset. So with the network dataset, we can do the network analysis. So now here we can see after we enter the network dataset, we can do this network analysis. For this today's purpose is to find out the hospital service error. So we are going to use the service error analysis. And here we can instance management. First, we need to import the hospitals, the stop. You can draw it on the map, and also if we have the hospital data. Without, and then we need to check the environment of the network analysis. Here we need to make sure the network dataset is the network dataset we just created, and here all this node, the rules can be set if you have these rules. Here we don't have this rule, so here we just keep it all at default. And then here we should set the parameters. Here we should set the service radius for each hospitals. Actually, in the reality life, different level of the hospitals have different service capabilities. So here, but here we just suppose that every hospitals have the capabilities, have the service capabilities for the 3,000 meters. Yeah. Because there are more than 80 hospitals, so here I want to copy it. So here I suppose this service area 3 kilometers. Actually, you can based on the reality to set the service radius. And here we can also save the node info and the edge info, but this is no use for us. But here we should check the endnet from center stop. So because we need this service from the hospital and the service stop, we can check all generate root, generate complex error, and okay. And after these settings, we can run it. Yes. Here we can see the results. Here we can see there are 3 temporary data sets generated. The one is the results, and one is the stops and the barrier, but we don't have it. Here we can center, just close it and just leave the build and so here we got the result. Here we can see each, we can open the hospital point. We can see it's a style for you. Here we use hospital. This one. Yeah. Here we can see each hospital's service error and the road related with the service error. Some hospitals don't have the service error because there is no road around it in 3 kilometers. So if you haven't filter the roads but keep all these roads in to analysis, it maybe have the results. And then, so here we finish it, we need to store the result. So we can say this is the final result we want to store, but this layer is stored in a temporary data. So we should copy this result to your data source, because the temporary data will be disappeared when if you don't save these data sets. You can copy data sets to the tenant data sets, the data source I created. Copy it. And then to current map. So it's the same. So here we don't worry if we close this application. and also close this workspace, your result it disappeared. And then the risk work is to lay out the results as usual. So here we can save the map and this service error analysis. Yeah. And then we can also create layout. Here we use the horizontal layout and the end the map. And the map. Set and adjust the map. So here we need an title and the legend. Here I just show you how to make the legend. Here we can see the city because the result is city data set, so there is no labels on it. So here we can create a region to respond this service error. Here we can just ungroup and ungroup and then delete. Just keep one. And here we can, what we can do is change this this polygon's color. Here we can style set, and here we can put the foreground color and background color. And here gradient model, we can use the linear, just like this. So here we can get colorful gradient. For the time limits, I wouldn't show all these layout operations. Here, I just to show you the result. When we finish it, here we can the result would be like this. And then, so that's all work for today. So the next, which also it is most important, is to analyze your results. So you may describe the features of the public service facilities service error distribution. So you can see which errors contains the most the hospitals and which errors are length of the hospitals. And also you can put forward suggestions to improve the capabilities of public service facilities and all other points you think you can on your results. So now let's go to the homework of today. So here also 2 requirements. Firstly, complete at least 1 network analysis, which can be the analysis of service area, just like I demonstrated. In addition, you can also try route planning or find the optimal routes from one location to another. And the second requirement is to complete the analysis of results. And also the submission format is no limit, so you can make a creative result for us and submit your results through the Google Classroom. And also, if you have any questions, you can leave your messages in Skype group, and then you can get the assignments and also submit your work through the Google Classroom. So I think that's pretty much for today's training. Thank you for your listening, and see you tomorrow in the same time. Bye.